Finding x and y intercepts. Today we are moving away from slope a little bit and we're looking at graphs and we're looking at how to find x and y intercepts. Before we do anything though, can we take just a second and look at just a sketch of a graph? If this is my graph and this is my line on my graph, let's make sure we understand kind of what we're talking about today, right? This point right here, that's my y-intercept, right, because it's crossing my y-axis. This point right here is my x-intercept because it's crossing my x-axis. So today when we talk about x-intercepts and y-intercepts, we're talking about these points and only these points in our graphs. All right, so we're going to go ahead and read these different instructions here. We're talking about how to find slope from standard form. And we haven't talked about standard form yet this year, but it is just when we have x and y on the same side. In order to solve for our intercepts, we need to cover up the x and the y. So I cover up the x and solve for y. In other words, if we know x is 0, then that y number is our y-intercepts. All right, if we want to find the x-intercept, we cover up the y, right? We know that y is 0, and we solve for the x, right? That's going to be our other one. Let me give you a better idea of what's happening here. Let me just kind of show you. All right. In our first example, we have 3x minus 2y equals 6. I like to go ahead and in my table understand that x is going to be 0 for one of my points and y is going to be 0 for another one of my points. So let's go ahead and let's focus on this one right here. What if x is 0? Do you guys agree that if x is 0, then I would have 3 times 0 minus 2y equals negative 6? In other words, I'd have 0, so just negative 2y equals negative 6. And then we just solve. Well, that's really super simple. Divide both sides by negative 2. I've got y equals 3. So when x is 0, y is 3. That's how we find intercepts. We plug in a 0 and then we solve for the other variable. Let's go ahead and let's take a look at the other one. Okay, this time my y is 0. So in my equation, I'm going to use 0 for my y value. So in other words, it goes away, right? So now I just have 3x equals negative 6, which means that x is equal to negative 2. All right, so x is equal to negative 2. These 2 points are my x and y intercepts. Now sometimes we forget which is which, but let's go ahead and let's look at my graph. Negative 2, 0 in blue. Once I see it on the graph, it's really easy to tell, okay, that's my x-intercept, right? Because I have an x value that's not 0. My other point is 0, 3, and that's my y-intercept. So if I wanted to graph this line, I could do it fairly easily now that I've got these points, right? And I could just say, okay, well, there's my line, right? There's my line. I'm graphed by my intercepts. All right, what is the 0? This is so important. Are you listening? This is super, super, super important, y'all. My 0 is always talking about, ready, always your x-intercept. Always your x-intercept. Never the y-intercept, always the x-intercept. So what's my x-intercept in this case? Negative 2. It's that simple. All right, negative 2. Now, be careful, be careful. I would definitely make sure that you graph these before you answer the questions of what is the x-intercept and what is the y-intercept, just to make sure that you can see it on the graph and you're not just looking at the table. Okay? All right. We're going to go ahead and we're going to look at example number 2. Here we go. All right, example number 2, x plus 2y equals 4. All right, let's deal with what happens when x is 0. If x is 0, then I have 0 plus 2y equals 4, which just is 2y is equal to 4, which means that y is equal to 2. When x is 0, y is 2. All right, let's try it with the other one. If I have x plus 2y equals 4, but now y is 0, well, then that means I've got x equals 4. Right, that's it. I don't even have to solve this one because if y goes away, I just have x, so x equals 4. So when x is 4, the y value is 0. Okay, let's look at this on the graph. Here we go. 4, 0 is right here. All right, so that's my x-intercept, right? And then we have 0, 2 for my y-intercept, 0, 2 for my y-intercept. All right, there's my line. You don't really have to graph the line if you don't want to, but I just do. So there's our line. There we go. Okay. What is the 0 of this graph? Okay, again, the 0 is always, let's do that in blue. Your 0 is always your x-intercepts. All right, so in this case, it is 4. Let's go ahead and let's turn this over to the back side. Turn this over to the back side, and we're doing the same thing, only now we have slope-intercept form. This is what we're used to. This is what we like better typically when we have y equals mx plus b. All right, the y-intercept is written as 0y, right? Something is used for y. X-intercept is x0. Guys, the main idea here is something is 0, right? Something is 0, and we just have to figure out which one is which. I don't have tables drawn for me, but I like the tables, so I'm going to draw myself a quick little table here. All right, let's see. First, let's find what happens when x is 0. All right, if I have x equals 0, then I've got y equals 8, right? The 2 times 0 is 0, so I just have y equals 8. So when x is 0, y is 8. Let's look what happens when the y value is 0, my other intercept, right? Because remember, these are zeros because the 2 points I'm talking about today are always on an axis, which means one of the coordinates in each pair is 0. So now I'm talking about what happens if y is 0. Well, this one's a little bit weirder, right? Because it looks like this. 0 equals 2x plus 8. Well, I need x, right? I need to solve for x. So let's solve this right here for x, which means 8's going to go away first. So I've got negative 8 equals 2x. All right, that's not that bad. Divide by 2, and I've got x is equal to negative 4. So negative 4, 0. Let's look at it on the graph here. Negative 4, 0 is my x-intercept. My y-intercept is at 0, 8. Okay, so that means that I've got my line right here. It's pretty close. All right, what is my 0? What is the 0? Okay, I can't stress this enough. If they're asking about the 0, they're talking about the x-intercept every single time. All right, so in this case, it is negative 4. Last but not least, one more example. Here we go. We've got to make a quick table. I just think it helps. And let's figure out what happens when x is 0 for this problem. All right, so y equals 1/3 times 0. Okay, well 1/3 times 0 is 0, so I guess y is just 0. So 0, 0 is one of my points. Okay, now let's look at what happens when the y value is 0. Let's see here, 1/3 x, and now we're saying y is 0. Well, we got to solve for x here, which means I need to get rid of the 1/3. But 0 divided by anything is still just 0. So I guess 0 also equals x. That's interesting. But I guess it kind of makes sense. You guys think about it. If I have an intercept here, then I don't have them anywhere else. It just would be a horizontal line or something, right? That would be strange. So my equation is, or my line rather, is just going through here. You don't really know how to draw this one because it could be going any which way through that point, so just don't really worry about it. Okay, we'll talk more about graphing later. So what is the 0? It is literally the x-intercept, which in this case is just 0. Okay, all right. Remember, the hardest thing about this is remembering to think of the table, remembering to just plug in a 0, solve for the variable that's left. Okay, guys, that's the main idea today. Put in a 0 for one of the variables, solve for the other one that's still there. Okay, good luck.